Here's a quiz problem I made up. It's kind of like problems number 11 and 12 from section 4.4. It's a little bit more complicated, but I think it kind of help you see what's going on with these problems. A 400 cubic foot open top rectangular tank's base has length equal to twice its width. So what we're basically saying is we have a 400 cubic foot open top rectangular tank, and its base has length equal to twice its width. If all five sides are made of the same material, find the length, width, and height of the tank that will use the least amount of material. All right, so I drew a sketch over here. Now remember, if it's got five sides, it's got a bottom and four sides. It doesn't have a top because it's open top. So I wrote some of this out just to save a little bit of time. And here's kind of my sketch, and this was the base, this was the width, and the length is twice the width. That's what we're saying. Now we have two unknowns there, or one unknown, excuse me, here for the width and the length, but we need something for the height, so we call that y. And they kind of suggest that in problem number 11. So we want to minimize the material. So that's going to actually be the surface area. In other words, we would go to the store, we'd buy 5 pieces of wood and put them together, so that would be area. So that's the more wood we buy, the more expensive it's going to be, so we want to minimize the amount of material, or the more material be. So we want to minimize that. So we're talking about surface area. And we've got the base, which is, and the area of this base would be just length times width. This is a rectangle down the bottom. So that would be just x times 2x. And then we've got two sides that have the same dimensions, and that's going to be the front and the back, and that's going to be x by y. So we got two sides there. And that'd be the front and the back, and that'd be 2 times x plus x times y. And then we've got the right side and the left side, and those are going to be bigger because this is longer than the front, so that's going to be 2x times y. We got 2 of those. So that's my surface area, and this is my primary equation. This is what I want to minimize, so this is what I'm going to take the derivative of. And hopefully it's going to go from negative to positive. Okay, so we can simplify this quite a bit. We have s equals, and that's going to be 2x squared. And then I've got, well, plus 2xy, and then 2 times 2 is plus 4xy. That's going to be 2x squared plus 6xy. All right. Now, this is, again, what I want to minimize. So I'm going to have to take the derivative of this, but I can't because I've got 2 unknowns. But we had some more information. We actually have what we call a constraint here. This is our secondary equation, or the constraint, because I know the volume must be 400 cubic feet. So that's going to lock everything in. Well, the volume is the length times the width times the height. So I could say that 400, which is the volume, equals the length. I'm sorry, I kind of mixed these up. This is actually you can kind of reverse these. That's the width, and that's the length. So I wrote width times length times height. Sorry about that. And that's going to be 2x squared times y, so I can simplify that. So I can say 400 equals 2x squared y. Width times the length times the height. And then what we want to do is we want to reduce this to one unknown, from 2 unknowns, so we can take the derivative, because we don't do multivariable yet. So I would just kind of, since I only have one y, I'm going to solve for y, so I'll just say y equals 400 divided by 2x squared. And then we could divide that a little bit, simplify that out, and so that would imply that y equals 200 over x squared. So this is my secondary equation. I'm going to put this into the primary equation to reduce it from 2 unknowns to 1 unknown. And now and I'll be able to write my area as a function of x, and that's going to be 2x squared plus 6x, and my y is now going to be what? 200 all over x squared. And then we can simplify that some more. So we got 2x squared, and then 6 times 200 is 1200, and x goes over x squared x times, so that's going to be plus 1200 over x. So we're all set and ready to take the derivative, so we'll do that. And the derivative of 2x squared is 4x. And now this 1200 is the same thing as 1200 times 1 over x, isn't it? And the derivative of 1 over x is negative 1 over x squared. So I say 1 over x squared, and then I just put the 1200 there. And there we have it. Okay, so we want to minimize this. So what we'll do is we'll get our calculator out and we'll put this in. So in y1, I'll put in 4x minus parentheses 1200 divided by x squared. So it looks something like that. So let's do that. So I'll turn the guy on. y1, so I'll put 4x minus parentheses 1200 divided by, you can see all these keystrokes here, x squared parentheses. Okay, and then like we've done before, hope you can, there you go, hope you can see all that. Okay, and then we'll just go to Zoom 6 again. We've been using that. That's been working pretty good. There's Zoom 6, and there you go. So it looks like, again, this is our derivative, so it looks like I'm going from negative to positive. That's really good, because if I'm going from negative to positive, selectional value of my derivative is here is negative, and then it's positive, because I'm below the line. So looks like I'm going to have a minimum there, because that's actually the derivative. Okay. So what is that? So we have to find that. So we go to second calculate. And we go to 0. And where's our left bound? So again, we're going to be looking over here. Look at how low this y is. So we want to get this to see where this changes from negative to positive. Oops, I just passed it there. This is a little bit better. So you can see it's negative here, it's still negative, and then it goes to positive. You see, watch those signs. So there's my cursor. It's a little bit easier to see than some of the other problems we've done. So that's going to be my left bound, so I'll press enter there. And then I'll arrow one over and get it up to the top, and that's going to be my right bound. And I'll press enter. Don't want to guess, and there's going to be my value. So x will be, I can write that over here, x can equal 6.69, we rounded off to two places, 695. Or, no, 69. That 4 is smaller than 5, so that's what we rounded off to two places. That's going to be the width. Now we're going to store that so we can find the other dimensions. So we'll go to home screen, second motor quit, and we'll press that. We'll store that in alpha A again, like we've done in other problems. And there's my width, and I know the length is twice that, so 2 times alpha A, enter, and that's going to give me my width, 2x. And that'd be 3.9 if I round it up to two places, 3.9. And I can store that. Well, I don't have to because we're not going to. We know that the volume better equal 400, so we can store that in just to check it, alpha B. And then what's my y? My y is 200 over x squared. Remember that from the top. Look over your notes. So y equals So I need 200 divided by x squared, that's going to give me the height, which is y, and that's 4 point. So that's going to be we can see that. Okay, so that's going to be (200) over x squared equals 4.46. So there's your width, there's your length, and there's your height. And I can store that in alpha C, and then I can just check that to make sure it does multiply to give 400. So alpha A times alpha B times alpha C, and I get 400. So those are the dimensions that will give us the least amount of material, or that we'll be using the least amount of material. Okay. So I hope that all makes sense.